There is a moment, somewhere between the stars, when a human being realizes they are never coming home. And in that silence, in that absolute darkness, what they see next has haunted scientists, philosophers, and space agencies for decades. We have sent humans beyond Earth's atmosphere over 500 times, and while most returned safely, the ones who did not, and the ones who came terrifyingly close, reported something that no training manual ever prepared them for: a visual and psychological experience so disorienting that it forced NASA to completely rethink how astronauts die in deep space. And more importantly, what happens to the human mind in the final moments when the universe closes in. Deep space is not like the movies. There is no dramatic explosion, no slow spinning into a fiery void. The reality is far stranger, far quieter, and in many ways, far more disturbing. What researchers have uncovered through a combination of mission data, survivor testimony, biological studies, and theoretical physics paints a picture of death in space that challenges everything we thought we understood about consciousness, light, and the human brain under cosmic conditions. This is not speculation. This is what the science actually says. To understand what an astronaut sees in those final moments, you first have to understand where they are, because deep space is not a place, it is an absence of everything familiar. Beyond the protective bubble of Earth's magnetic field, beyond even the relatively safe orbit of the International Space Station, astronauts traveling toward the Moon, Mars, or beyond enter a region of space saturated with galactic cosmic rays, high-energy particles fired from dying stars and colliding galaxies across billions of light-years of distance. These particles move at nearly the speed of light. They pass through metal, they pass through flesh, and critically, they pass directly through the human eye and the human brain. Apollo astronauts were the first to document this. Lying in the darkness of their capsules, eyes closed, en route to the moon, they began seeing things. Flashes of white light, streaks of blue and gold, geometric shapes that appeared from nowhere. Astronaut Buzz Aldrin described them as bright streaks, and nearly every Apollo crew member reported the same phenomenon. At first, scientists assumed it was a visual quirk, a minor annoyance, but when they dug deeper into the data, they realized these light flashes were cosmic rays physically striking the retina and the visual cortex of the brain, creating the perception of light where there was none. The brain was seeing the universe whether it wanted to or not. Now here is where it gets deeply unsettling. In normal circumstances, the human brain receives light, processes it, and constructs a coherent image of reality. But in deep space, bombarded by cosmic radiation, that process begins to degrade. Studies conducted after long-duration spaceflight, particularly on astronauts returning from the International Space Station, revealed structural changes in the brain, white matter lesions, shifts in the ventricles, and altered connectivity in regions responsible for vision and spatial awareness. Scott Kelly, who spent a year aboard the ISS, reported persistent changes in his vision afterward. Astronauts on longer missions experience what researchers now call space-associated neuroocular syndrome, a condition where fluid pressure builds behind the eye, physically deforming the shape of the eyeball and distorting vision in ways that cannot simply be corrected with glasses. But if those changes happen on the relatively sheltered ISS, still inside low Earth orbit, still partially protected by Earth's magnetic field, the question that researchers have been quietly wrestling with is this: what happens to the human visual system on a 6-month journey to Mars, fully exposed to the unshielded cosmic radiation of deep space? And then, what happens in a catastrophic scenario, a spacecraft failure, a loss of oxygen, a fatal radiation event, when the brain begins to shut down in that environment? The data suggests something extraordinary. When the human brain begins to experience oxygen deprivation, a condition called hypoxia, it does not simply go dark like a screen being switched off. Instead, neurons begin firing in rapid, uncontrolled bursts. The visual cortex, one of the most energetically demanding regions of the brain, becomes hyperactive in its final moments. Survivors of near-death experiences, including several astronauts and test pilots who briefly lost consciousness during high-G training or pressure suit failures, have consistently described the same phenomenon, an intensification of visual experience, not a dimming. Tunnels of light, extraordinary color saturation, a sensation of the visual field expanding rather than contracting. One NASA test pilot described it as seeing everything at once. Now, some scientists argue this is simply a neurological artifact, the brain misfiring as it loses power, the same way a computer might display corrupted graphics before shutting down. And that explanation is entirely plausible, but it is not the only one on the table, and this is where the science becomes genuinely contested. A separate line of research, drawing on quantum biology and theoretical neuroscience, proposes that what dying astronauts might perceive is not random noise, but something structured, something that emerges from the fundamental physics of how consciousness interacts with space-time under extreme conditions. Dr. Sam Parnia at NYU Langone has studied cardiac arrest patients and found evidence of conscious awareness persisting for measurable periods after clinical death. Separately, physicists studying the behavior of the brain under radiation exposure have noted that cosmic rays, the very same particles that cause those light flashes in living astronauts, interact with neural tissue in ways that are not yet fully understood. The brain is, after all, an electromagnetic organ, and in an environment saturated with the most energetic electromagnetic particles in the known universe, what it experiences may be genuinely unlike anything that happens on Earth. Consider what surrounds a dying astronaut in deep space. They're enclosed in a region of near-perfect vacuum, where temperatures swing between positive 150 and negative 150 degrees Celsius within meters of each other. They are bathed in radiation from thousands of dead stars, some of it billions of years old, having traveled across a measureless distance to arrive at precisely that moment and pass through precisely that human brain. The light they would see, the artificial flashes and the geometric hallucinations and the luminous tunnel effects would be in part caused by the literal light of the cosmos striking their nervous system directly. There is something almost poetic about that, and something deeply sobering. What this means for the future of human spaceflight is enormous. NASA and ESA have both acknowledged that deep space radiation is one of the single greatest obstacles to a crewed mission to Mars. It is not the distance, it is not the food or the water or the psychological isolation, though those matter too. It is the radiation. A crew traveling to Mars and back would absorb approximately 600 millisieverts of radiation, roughly the equivalent of receiving a full-body CT scan every 5 days for 8 months. Long before they arrived at Mars, their visual systems would be compromised, their cognitive function would be measurably impaired, and in a worst-case scenario, a major solar particle event during the journey, an unshielded crew could receive a lethal dose in a matter of hours. In that scenario, in those final hours, what the data and the survivor testimony and the neuroscience all converge on suggesting is this: the astronauts would not go quietly. The brain, even a dying brain, even a brain in a radiation-soaked metal capsule 100 million miles from the nearest other human being, would generate light from within. It would construct images. It would try, in its most fundamental way, to make sense of the universe around it using the only tool it has ever had: perception itself. Zoom out further still, and this question stops being just about astronauts. It becomes a question about consciousness itself in a cosmic context. We are biological beings who evolved under one specific star on one specific planet, calibrated by millions of years of evolution to process the narrow band of electromagnetic radiation that our star produces. Deep space operates by entirely different rules. The light there is ancient, violent, and indifferent. And when a human brain meets that environment at its limits, something happens at the intersection of biology and physics and consciousness that science has not yet fully explained. That gap, That unanswered space between the last thing the data can tell us and the first thing no instrument has ever been able to measure is perhaps the most profound mystery in all of human space exploration. We know what the body does. We know what the brain does. But what does a mind do in the last moments, surrounded by the oldest light in the universe, with nothing between it and the infinite? That question doesn't have an answer yet. And maybe that's exactly why we keep looking up.